In this video, we will continue practicing differentiation. So we begin by differentiating the function root x times secant x. The observation I make is that we have root x, think of it as one function, times secant x, which is another function. So this is an ideal candidate for us to apply the product rule. The product rule tells us that dy dx will be equal to the derivative of the first. The derivative of square root is 1 over 2 square roots, multiplied by the second function, secant, plus the first times the derivative of the second. The derivative of secant is secant tangent. And this gives us a perfectly nice formula for the derivative of the given function. So next, let's think about differentiating the function y equals sine of x squared. And in order to do so, you might recall from your past experience, we need another formula. We need something called the chain rule. The reason is we have a composition. We have an outside function sine, and we've plugged inside it another function x squared. So as a reminder, what the chain rule tells us is that if we want to differentiate a composition, what we do in words is we take the derivative of the outside, evaluate it at the inside, multiplied by the derivative of the inside. So let me rewrite down our function. So we're trying to differentiate, I'll call it big F of x to agree with our chain rule formula, just for fun. And this is equal to sine of x squared. So you see that you have this outside function, sine, and this inside function, x squared. So just working through this in words exactly how the chain rule describes it. We take the derivative of sine, which is cosine. We evaluate it at the inside function. So think that inside function is always getting plugged back in. And then we multiply it by the derivative of the inside function. So in this case, dy dx is 2x cosine of x squared. Let's look at one more example that involves using the chain rule. Let's differentiate the given function. We have x plus 1 over x minus 1 being cubed. And this is a composition of functions. You see the inside function, which is usually what kind of jumps out at us, x plus 1 over x minus 1. And the outside function is the function which cubes. So let's just walk our way through this. So the chain rule tells us we differentiate the outside function. The 3 comes down front. The new power is 1 less. We plug that inside function in, x plus 1 over x minus 1. So that inside function gets plugged in the derivative. And then we need to multiply by the derivative of the inside function. And it's perfectly fine for us to have to use multiple rules of differentiation all in a single problem. The derivative of x plus 1 over x minus 1 is a derivative of a quotient, which requires a quotient rule. So out front we have the 3 times x plus 1 over x minus 1 squared multiplied by this derivative. The quotient rule tells us low d high. The derivative of that function in the top is 1 minus high d low, the derivative of the function in the bottom is 1, all divided by low squared. And let's go ahead and just simplify this a little bit. So we have 3 times x plus 1 squared over x minus 1 squared multiplied by, let's see here, we have an x minus 1 squared in the bottom. And in the top, note that this 1 distributes through, and then here as well. So you would have x minus 1 minus x minus 1. So x minus x goes away. You're left with a minus 2. And if we take this minus 2 that's left and hit it with the 3, that would be minus 6. We have an x plus 1 squared. and we have an x minus 1 squared times an x minus 1 squared, which is x minus 1 to the 4th.